Everyone, welcome back to channel. In this video, we will be discussing about the last problem of today's biweekly contest, shortest impossible sequence of rules. The problem states that you are given an integer array rules of length n and a integer k. So what this integer array denotes is the value you get after rolling a k-sided dice. So you are rolling a k-sided dice n number of times, and whatever value you get every time, you just uh, aggregate them in this array. Like this array is found from that. Now, what you need to find is the shortest sequence of roll that cannot be taken from this given array of rolls. So, for example, let's say this is what rolls array is, and value of k is 4. So basically, the dice is four-sided. I like when you roll the dice, either you will get 1, 2, 3, or 4. Now here you can see you can get like 1, right? So and you can get 2, you can get 3, you can get 4 as well. So because you can get 1, 2, 3, 4, roll of size of length 1 is something that is present in this roles array. So what we need to find is the sequence that cannot be taken. So because 1, 2, 3, and 4 are present in this sequence, size like sequence of length 1 is not possible. Similarly, if you try sequence of length 2, 1, 1, 1, 2, 1, 3, 1, 4, up to 4, 4, you can actually see that everything can be taken from this array. Hence, sequence of roll like length 2 is also not possible. Now for sequence of length 3, you can try several possible cases. One such possible case 1, 4, 2. You can see you can't actually take any subsequence of this array such that you will get 1, 4, 2. Hence, there exists a role of length 3 that cannot be taken from this given sequence of roles. Hence, the answer is 3. So hope the question makes sense. Let's just see how to solve it. Now, first of all, we need to find the shortest sequence of rows, right? So obviously we will start with length 1, like a sequence of roll of length 1. Then we will try length 2, we will try length 3, and so on and so forth. So basically, for length 1, we will check whether 1, 2, 3, and 4, like we are assuming that k equals to 4 for simplicity, but it would work for any k. So 1, 2, 3, and 4, we will check whether 1, 2, 3, and 4 is present in this rows array or not. If they are not, if they are, length 1 is not possible. Now, then we will go ahead and find check length 2. So for length 2, what we will check everything that is starting from 1, like 1, 1, 1, 2, 1, 3, 1, 4, whether they are present in this array or not. Similarly, for length 2, like for length 2, then we will check everything starting from 2, then starting from 3, and then starting from 4. If everything is present in this sequence, like we can actually bring some subsequences such that everything here can be formed. Then we will move on to length 3. So that's how we will proceed. Now, length for checking whether a sequence of length 1 is possible or not, it's very easy, right? Because what you need to do, you need to just check whether 1, 2, 3, and 4 is present in this array or not. If any of them is not present, you will just return answer 1, because that means that a sequence of length 1 of that particular integer is something that cannot be formed. So what happens with length 2? So for length 2, what actually you need to do is you need to find a 1 such that there exists a 1 after it, there exists a 2 after it, there exists a 3 after it, and there exists a 4 after it. If you are able to find one such one, then it means that everything starting from 1 of length 2 can be formed, right? Similarly, you will see this for 2. So everything starting from 2, if that can be formed or not. So you will actually find one such 2 such that it is followed by 1, 2, 3, or 4. So let's just take an example. The example, let's say, is this one. So this one, you can see it is actually followed by this one, 2, 3, and 4. So in a way, you can actually form everything of length 2 starting from 1, because these will substitute the remaining integer. So that's the like motive. So what we are doing is we are trying to find one such one that is of type 2. Like by type 2 what we mean that there exists a one such that it is followed by 1 2 3 and 4. So basically of everything of length 2 starting with 1 can be formed. Then we will say that a 1 is of type 2. Similarly, we need to find one such 2 of type 2. Basically everything starting from 2 can be formed, and we need to find one such 3, and we need to find one such 4. If we are able to find all of them, 1 2 3 and 4, if we are able to find a 1 of type 2, a 2 of type 2, a 3 of type 2, a 4 of type 2, then it means that everything starting from 1 can be formed, starting from 2 can be formed, starting from 3 can be formed, and starting from 4 also can be formed. So we will then try for next length, which is L equals to 3. So hope this makes sense. What we started is we started with length 1. For length 1, we said that it is easy to check because we just need to check whether this number is present in this entire array or not. Now for length equals to 2, what we are saying is we need to actually check whether there is a 1 such that it is followed by every integer from 1 to k. In this case from 1 to 4. If there exists such a one, then we will try to find such a 2, 3 and 4. If we are able to find one such 1, 2, 3 and 4, then it means everything starting from 1 can be formed, everything starting from 2 can be formed, everything starting from 3 can be formed, and everything starting from 4 can be formed, which in turn means that everything of length 2 can be formed. So we will try with 3. So how we will check, it's different question. What we are checking, I hope that makes sense. So now for L equals to 3, it will look something like this. So let's just try to focus on this piece first. So for L equals to 3, it will look something like this. So we have to find one such one which is followed by a type 2 one. So by type 2 one, what we mean is everything of length 2 can be formed which is starting from 1. So everything of length 2 can be formed which is starting from 1. Okay. So what we need to find is we need to find a one such that it is followed by a type 2 one, it is followed by a type 2 2, it is followed by a type 2 3, and it is followed by a type 2 4. If we are able to find one such one, it means we can form everything of length 3 starting from 1. Let me just try to repeat. So what we have started with is we will say that first we will try length equals to 1. So for length equals to 1, we will say whether it exists in the array or not. That should be fine to check whether we should return 1 as an answer or not. For 2, what we check is whether there exists a 1 that is followed by 1, 2, 3, and 4. Similarly, we check whether there exists a 2 which is followed by 1, 2, 3, 3 and 4, and so on and so forth. If everything, like if there is a 1, there is one such 1, there is one such 2, one such 3, and one such 4, then we can say that everything of length 2 can be formed. Then we'll move to length 3. And for length 3, what we will check whether there exists a 1 such that it is followed by type 2 1, type 2 2, type 2 3, type 2 4. Similarly, we'll check whether there exists a 2 which is followed by type 2 1, type 2 2, type 2 3, type 2 4. So basically what we're checking is the same thing but with type 2. So in a way, let's just try to understand this one is a type 2 one because it actually it has like it is of this type. Basically you can form everything of length 2 starting from this one. So you can form 1 2, 1 3, 1 4, and 1 1 starting from this one. So this one is of type 2. So what you need to do for type 3 1, like you need to find one type 3 1 one type 32, one type 33, and one type 34. If you are able to find everything of type 3, then 3 is also not the answer. You will try with 4. So hope you are getting what we are trying to do. We are trying to generalize it. What we are saying is, if you are able to find all 1, 2, 3, 4 of type 3, then you will check with 4. Then you will check whether you are able to find all 1, 2, 3, 4 of type 4. Then you will go with L equals to 5. And then you will check the same thing. So until you exhaust the entire thing. So what we problem is now reduced to finding the types of every integers here. So for example, this one is of type 1 because you can't actually form anything of length 2 from this one. Similarly, this 3 is of type 2 because you can actually form 3 1, 3 2, 3 3, 3 4 from this 3. You can see 3 1, 3 2, 3 3, 3 4. Everything can be formed from this 3. That's where it is type 2. So after you figured out the types of every integer, then you will just take the minimum of 1, 2, 3, and 4. So there is a type 3 4, there is a type 3 2, but there isn't a type 3 1. So because there is not a type 3 1, answer would be 3, right? Because you can't actually form everything starting from 1 of length 3. So the hence answer would be 3. So hope you are getting like what we actually need to do now is we just need to find out the type of every integers. That's it. So the problem statement is now reduced. Problem statement is just we need to assign a label ti to each of the values. Now let's just try to understand how we will label a particular element. Let's say we are trying to label this 2. Let's say the label is tx. We need to find this value of x. So tx will be 2 if there exists 1, 2, 3, 4 up to k of t1 after this, right? Similarly, tx can be 3 if there exists everything up till k of type 2. So what will be the value of tx? Let's say like k equals to 4 again. Let's assume. Now let's say the largest value of 1 after this 2, like after this index in this part of the array, largest value of 1 is t4, largest value of 2 is t5, largest value of 3 is t9, and largest value of 4 is t3. So what exactly would be the value of x here? The value of x would be uh, t4. Why? The reason being, you can see you can actually form like for let's say let's say we'll check x equals to 4. Okay, so for x equals to 4, what we need everything to be 3, right? Like we need 1 of type 3, 2 of type 3, 3 of type 3, and so on and so forth. So here we can see everything of type 3 exists. So basically type 5 actually means that everything from 1, 2, 3, 4 already exists. So everything of type 3 exists. But for x equals to 5, what we would need to check, everything of type 4 exists or not. So everything of type 4 doesn't exist. See, 4 highest is type 3. So type 4 of 4 doesn't exist. Hence 5 can't be possible. So what exactly is the label? Label of any element is just the minimum of the largest labels of every distinct integers from 1 to k. So in a way, we just take the minimum of these labels and just do a plus 1. That would be the label of the current element. So hope you get this. So the problem was just to find out label, and to find out label, what we say is the value would be the minimum of every label to its right. So minimum of every label of the last element. So why last? Like the largest, last is the largest type. Last will have the largest type. So now what exactly you need to do? You need to find a data structure that can insert an element, because when you when you let's say you figure out the type of this 2. So after you figure out the type of this 2 is the largest 2, right? So basically you need to insert a new element in your data structure, and you need to remove the element, because once, let's say, previously the largest type of 2 was T5, but now it is T6. So you need to remove T5 and insert T6. So that's where you need to do this two operation. And finally you need to find the minimum, because that's what will give you the label of the next element. So they just try to, like, first of all, like, this data structure is nothing but a set, right? Like, you can insert it, you can delete it, and you can you can also find the minimum. So let's just try to find out the type, or let's just try to iterate over everything with this example. So initially type of everything is 0. Basically we can't from anything, from any of the we can't from anything, either of length 1, length 2, length 3, length 4, of anything. Now we start with 1, because why we are starting from the begin, like, ending instead of starting, because we want to find out the, like, we will go from the smallest type to the largest type, right? So largest type would be somewhere here and smallest type would be somewhere here. So for finding out the type of this one, we would need the type of everything to the left. So that's where we are starting from the last element. So first we'll see this one. So what would be the type of this one? Type of this one would be the minimum of this, which is 0 plus 1. So this would be of type 1. So what it means is, we can form, like, with only this part of the array, we can form a sequence of length 1, which is starting from 1. Now, what is the type of this 4? The type of this 4 would be T1 again, because, okay, one more thing, like, before, like, once, now the type of this 1 is updated to 1, like, the maximum type of 1 is now 1, so we will update this to 1. Now we will find the type of 4, again minimum is 0, so type would be 1. So this is T1. Now we will find the type of this 2. So again, like, 4 is updated to 1, so we will update this to 1. This will now become 1. Okay. So now we find the type of 2. Again, the minimum of all this is 0. So type of 2 would be 1. And we will update this to 1. Okay. Now what would, like, we will find the value of type now we will find the type of this element 3. The minimum is 0. So type would be T1, 0 plus 1. Now we will update this to 1. Okay. Now what will the value of this 3? It is T2, because now you can see the minimum is 1, right? So value, like, this is of type 2. What actually this mean? This mean that everything starting from 3 of length 2 can be formed. So 3 1, 3 2, 3 3, 3 4 can be formed. And you can see it is indeed true. We can form 3 1, 3 2, 3 3, and 3 4, right? So that's actually satisfied that it is of type 2. Now we will update the value of 3 to 2. Now what is the value of this 2? Again, this will be of type 2, because minimum is 1, right? So now we'll update this to 2. Now what is the value of this 1? This will be again T2, because the minimum is 1. So we will now update this 1 to 2. Now what is the value of this 2? It will be again T2, because the minimum is still 1. And we don't need to update, because 2, like, 2 value is already 2. Now what is the value of this 4? 4 will be T2, because this minimum is 1 and 1 plus 1 is 2. Now we'll update this 4 to 2. Now after we have done this, whatever is the minimum is something that we can form. So minimum is 2. So it means everything starting from 1 of length 2 can be formed. Everything starting from 2 of length 2 can be formed. Everything starting from 3 of length 2 can be formed. And everything starting from 4 of length 2 can be formed. So what would be the answer? Answer would be 3. Like, we can form everything starting from 1 2 3 4 of length 2. So we can't form at least one of the sequence of length 3. That's where the maximum is not 3. So hence the answer is 3. Let's just quickly look at the code. The code is very simple. As we have discussed, we will use set for set as our data structure. So initially everything is 0. So this is type, and this is the uh, like roll number 1, 2, 3, 4, and so on up to k. So for everything we'll insert a 0. Now we will just iterate over the roles, find the minimum. Minimum is the beginning in the set, right? So we'll find the minimum, and we will erase the previous value of role, right? And we'll update the new value as minimum plus 1, and we will again insert the new value. So once this entire thing is done, whatever is the minimum, everything of that length can be found. The answer would be plus that minimum plus 1, because everything of that length can be formed. So it means length of 1 greater than that can't be formed. Hence the answer is 1. Answer is minimum plus 1. Hope this solution makes sense. If you have any doubts in this problem, feel free to post them in the comment section below. I will definitely answer them. And one last time, they just iterate over the entire solution. The solution was, we have tried to generalize it. What we have said is, we like for 1 it is simple, we just check whether it exists in the array or not. Now for length 2, what we said is, we need to find a 1 such that there exists a 1 after it, there exists a 2 after it, there exists a 3 after it, and there exists a 4 after it. If there exists one such one, it means everything of length 2 can be formed. Hence, that one, like that one is of type 2. Like everything of length 2 starting from that one can be formed. So if everything of type 2 is there from 1 to k, it means everything of length 2 can be formed, right? And hence the answer, like we'll check the next integer, which is l equals to 3. Now for 3, again we will check whether everything of length 3 can be formed. How we will check that? We'll check whether everything of length 1, everything of length 3 starting from 1 can be formed or not. Everything of length 3 starting from 2 can be formed or not. Everything of length 3 starting from 3 can be formed or not. Everything of length 3 starting from 4 can be formed or not. And how we will check that? For checking whether everything of length 3 starting from 1 can be formed or not, we will just find, we will just see that whether there exists everything from 1 to k which is of type 2. And if there exists one such, one such that everything after, like there after this type 2, everything of type 2 is present, then we will say that everything of length 3 can be formed that is starting from 1. So once everything, uh, once we will do this for all the integers from 1 to k, and every integer from 1 to k satisfies this, we will say that let's try the next integer. So that's the solution is just. If you don't understand it, I will recommend to rewatch the video. I am sure you will get it. Again, any doubts, post them in the comment section below. And I will see you tomorrow. Thank you.